Yo le preguntaba, ¿eso es la necesidad de Sí, ahí está. Incluso ahí debe estar transmitiendo, quiero probar si está transmitiendo o no. Sí,
Un, dos, tres, probando, un, dos, tres, probando.
sí, está como
El de acá en el de allá. Pero no hay opción de audio. No, yo creo que ahí vamos bien.
¿Alguna inquietud o si se le cae el internet? No se lo sabes.
Listo, muchas gracias.
¿Sí?
Si es que no lo veo aquí. Un, dos, tres, probando, 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 probando. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Buenos días, José Manuel, ¿me escuchas? José Manuel, probando, 1, 2, 3. Buenos días, probando el sonido para las conferencias del día de hoy del segundo Seminario Internacional Presente y Futuro de la Protección contra Incendios. Estamos realizando las pruebas finales para dar inicio a la transmisión del evento.
distintas leyes. En caso de votación, usted de la Cámara evite devolverse. Utilice la salida de emergencia. Identifique los conductores de evacuación, vaya a los centros de encuentro y permanezca aquí esperando instrucciones. Muchas gracias. Cuidamos a ustedes.
Bueno, muy buenos días para todos. Bienvenidos al segundo seminario Presente y Futuro de la Protección contra Incendios, organizado por ANRACI Colombia, con un especial apoyo del Cuerpo Oficial de Bomberos de Medellín, del DAGRET, aquí localmente. En nuestra mesa de instalación tenemos al ingeniero Michael Bosman, representante hoy día de la International Fire Sprinkler Association, y además representante de Viking. Hoy él tiene esas dos camisetas para nuestro evento. También damos un saludo especial al ingeniero Gustavo Londoño, coordinador de la Comisión de Riesgos Tecnológicos del Valle de Aburrá, aquí en Antioquia. Gustavo, bienvenido. Damos también un agradecimiento muy especial, como les decía previamente, al DAGRET, al capitán Carlos Cartagena, al doctor Diego, al doctor Camilo, nuestros asociados que hoy día nos acompañan, ASEQUIP, ACNISAS, Ashes Fire Colombia, Colombia Fire Bombs, EHR, Fire Marshal de Colombia, Fire Protección de Colombia, General Fire Control, Globe Fire Sprinkler, EDAGA SA, Hidráulica y Saneamiento, Implementos de Seguridad Industrial, INPLESEC, INCOLDEX, INSECOL, ONC, OSH Ingeniería, PRODESEC, RCI, Ingeniería y Montaje, Servicios Integrales Ingeniería de Colombia, CERINCO, Sistemas de Protección contra Incendios, SPCI, Tecnofuego SAS, Texas SAS, Reliable Automatic Sprinkler, Tyco Services, Balin Ingeniería, Pictablic y Viking Corporation. Gracias a nuestros asociados tenemos hoy día este evento que ha sido un evento abierto a la comunidad, como ustedes saben, sin costo, con la finalidad y el objetivo fundamental de nuestra organización de ayudar en la promoción de una cultura de protección contra incendios, de prevención de emergencias. Tenemos conferencistas hoy de Brasil, Colombia, España, Estados Unidos, México y Turquía, y las organizaciones que han contribuido especialmente para el desarrollo de este evento tenemos las siguientes: ABSPK de Brasil, ANRACI México, ANRACI Colombia, Área Metropolitana del Valle de Aburrá, la Asociación de Ingeniería Sísmica, CIPE, el Departamento Administrativo de Gestión del Riesgo de Desastres DAGRET de Medellín, Duyar Bad Company, FM Global, la International Fire Sprinkler Association, la Sociedad Colombiana de Ingenieros, UL, Pictablic y Viking. Y a ustedes, nuestro público, les agradecemos su asistencia y queremos un poco que sepamos quiénes estamos. Vamos a mencionar algunas de las compañías que se inscribieron, no todos, pues porque la lista es bastante extensa, pero sí para que tengamos una idea general de quiénes son los integrantes de este auditorio. Allianz Seguro, ARL Sura, Astromaquinaria, AXA Colpatria, Cuerpo de Bomberos Oficiales y Voluntarios del país, de Bello, de Envigado, de Funza, de Girón, de La Pintada, de la Unión Valle del Cauca, de Medellín, de Cajicá, de Río Negro, Sabaneta, Cañas Gordas, Envigado, Jumbo, Yarumal, Bogotá, de Cementos Argos, del SENA, del Centro de Desarrollo para el Hábitat y la Construcción, de la Regional Antioquia, Cerro Matoso, Colmena Seguros, Galletas Noel, Corantioquia, Empresas Públicas de Medellín, Integral, Marsh, Mexichen, Municipio de Bello, Nutresa, Oficina de Gestión de Riesgo de Envigado, Politécnico Colombiano Jaime y Sasa Cadavid, Productos Alimenticios Doria, Seguros Generales Suramericana, Universidad Nacional, Unidad Nacional de Gestión del Riesgo de Desastres, Uniminuto, Sede Bello y Universidad de Antioquia. Esto para significar que es un evento no únicamente de las empresas especialistas en desarrollar sistemas de protección contra incendios, sino también de todas nuestras partes interesadas, nuestros clientes, nuestros usuarios, las aseguradoras. Estamos conscientes de que este es un tema que nos toca a todos. La protección contra incendios es algo transversal. Desafortunadamente en los últimos días aquí en la ciudad de Medellín hemos tenido un par de incidentes muy graves. La semana pasada en un barrio que fue arrasado pues prácticamente por un incendio, y el día de ayer en Peldar con un incidente también bastante importante. Del mismo modo, para los que estén interesados en la certificación del SENA, el SENA nos va a certificar la asistencia a este evento. Para las personas que quieran este certificado deben registrarse en oferta.sofiaplus.edu.co y hacen el registro. Si lo van a buscar por Google, Sofía Plus, y buscan el registro. Nosotros le proporcionamos al SENA la base de datos de los asistentes, y el SENA hace cruce con las personas que hayan registrado su presencia en este evento, y de esta forma les envían su certificado digital. Queremos darle la palabra a Mike en representación de IFSA para un pequeño saludo para ustedes.
Thank you, Gustavo. I really appreciate being here. Your beautiful city. It's good to see this wide interest in the field of fire protection. Several years ago, the International Fire Sprinkler Association was created to promote the fire sprinkler concept. That's the way we crafted that goal. Granted, it was in American and English origin, but we had recognized the benefits to society of fire sprinklers and how it can work in conjunction with both the fire service and the installers to provide not only life safety but property protection as our economies grow and our businesses expand. So under that guise, we're very happy to be part of this organization, always looking to support any effort we can with information and data, and help the local effort to promote that fire sprinkler concept. So on behalf of both the IFSA and NFSA, I welcome you and wish you a good conference and look forward to some interesting discussions.
Queremos dar ahora la palabra al ingeniero Gustavo Londoño, del área metropolitana del Valle de Aburrá.
Buenos días para todos y todas. Bueno, como Hugo nos manifestó, nosotros tenemos una comisión de riesgos tecnológicos que funciona activamente hace muchos años. El área metropolitana pues viene coordinando esta comisión desde hace 15 años de mi cabeza. De verdad que el tema de incendios a nosotros siempre nos ha preocupado bastante, porque da pesar las cosas que nos han sucedido. En la presentación que voy a hacer esta tarde, espero que no me la pierdan, voy a presentar precisamente los casos más graves de incendios que han ocurrido aquí en el Valle de Aburrá. Son bien graves, han dejado víctimas, han dejado heridos, han dejado intoxicados, han dejado la infraestructura totalmente perdida. La continuidad de los negocios de esos incendios no fue factible, o sea, se perdió el negocio completamente. Hay otros incendios menores que también ocurren, digamos, cotidianamente, pero que no los vemos, no los percibimos, no salen por las noticias. Este tema normalmente no es de mucha noticia. Es más el que ocurre cuando es el natural, cuando es el deslizamiento, cuando es la inundación, cuando es el temblor, etc., o la avenida torrencial, pero realmente cuando pasa un riesgo tecnológico es poco el despliegue publicitario que se da, y la verdad es que son bien importantes y pasan. Yo, en primer lugar, quiero darle un saludo muy especial a al doctor que nos acompaña desde Estados Unidos, pues con su presencia. Esta es una ciudad muy bonita, las mujeres, el tiempo y el clima son muy bonitos para que los disfruten. De hecho, si mira para el auditorio hay bastantes mujeres bien bonitas, los hombres no tanto, ¿sí? A mí ya me pasó, yo era joven y bello, ahora solamente soy bello. Tener ANRACI como aliado para nosotros ha sido muy beneficioso, precisamente porque, como les decía, por esa preocupación del tema de los incendios, entonces lo que queremos es que la gente se capacite muy bien sobre este tema, porque yo pienso que en la prevención es donde está el quid del asunto, ¿sí? Prevenir y estar preparados para el tema de los incendios en las empresas es fundamental, por dos cosas. La primera, porque salva vidas, es lo primero, ¿sí? Y lo segundo, porque precisamente nos salva de una contaminación ambiental y nos salva de la pérdida de infraestructura de la empresa y de la continuidad del negocio. Yo pienso que, como lo dijo también Hugo, este evento pues tuvo dos antecedentes que no sé si era un presagio de que realmente lo estamos necesitando mucho o qué, pero parece paradójico que hoy estuviéramos aquí parados y nos hayan ocurrido pues en menos de 5 días 2 incendios graves, que fue el de Moravia, en esa zona pues tan degradada, en esa zona que es económicamente pues gente que vive digamos son de muy bajos recursos. Para las personas que nos visitan y que no conocen, pues es un barrio en donde hay mucha problemática social, económica, etcétera, donde vive gente muy pobre y precisamente quedaron 350 familias totalmente en la calle. En este momento los tenemos albergados en un lugar que se llama El Bosque. Se les está prestando toda la ayuda, pues por eso es que no está aquí ni Diego, ni Camilo, ni todas las personas que vengan a estar aquí del Lagrede, pues porque en este momento están totalmente volcados atendiendo esa necesidad de esas personas que tanto lo necesitan. Y ayer en la noche tuvimos el otro evento que fue el incendio en Peldar. Pues para nadie es un secreto, al menos que vivimos acá, pues que Peldar es la mayor productora de vidrio en el país. Tiene su planta aquí en Envigado. Estaban fundiendo precisamente vidrio y cayó sobre un aceite, y el aceite pues inmediatamente se incendió y parte de la empresa pues sufrió un gran incendio, pero afortunadamente por la reacción inmediata de bomberos de Envigado, pues que está muy cerca, y también bomberos de Itagüí, pues la deflagración fue controlada rápidamente. La Comisión de Riesgos Tecnológicos, como les comentaba, es una comisión que, vuelvo y lo repito, se ha venido preocupando mucho por este tema. ANRACI, estamos de cumpleaños, ¿sí? Hicimos un matrimonio con ANRACI hace un año precisamente, ¿sí? Íbamos a hacer un convenio, ¿sí? Pero pues para que nos colaboraran, para que los eventos que ellos hacen, que son de muy alto nivel, ustedes van a dar cuenta que este evento va a ser de muy alto nivel, ¿sí? Nuevamente, gracias por hacerlo aquí, de verdad, porque hubieran podido haber hecho en Bogotá tranquilamente, porque ellos tienen su sede principal en Bogotá, pero prefirieron hacerlo aquí, y eso ya a mí me parece que es una ventaja grande para todos los que están ahí en el público y para nosotros, integrantes de la Comisión de Riesgos Tecnológicos. De verdad que muchas gracias por haberlo hecho acá, y ojalá que nos vaya muy bien en este evento, porque, vuelvo y les digo, es de alto nivel. La idea es que en esta comisión ustedes tienen también todo el apoyo. Nosotros operamos, como les digo, desde hace 15 años, somos muy poco conocidos, pero la verdad es que siempre estamos apoyando y asesorando, porque esa es la función principal de nuestra comisión. Cada que ocurre un evento de riesgo tecnológico, estamos allí presentes, asesorando, estamos detrás de las cámaras, no estamos al frente, sino detrás. Otra cosa que hacemos muy importante es que capacitamos hacia adentro de la comisión a nuestros integrantes y también capacitamos hacia afuera. Esta es una de las precisamente de las alianzas estratégicas que hicimos. Como les decía, íbamos a hacer un convenio, pero preferimos que ANRACI estuviera sentada en nuestra comisión, y desde hace un año lo están haciendo, y ya hemos capacitado a todos los comités municipales de gestión del riesgo de desastres, a los directores, ya los hemos capacitado en el tema de incendios, y próximamente vamos a seguir con la capacitación a todas las empresas que pertenecen a COPI, FENALCO y la ANRACI. Esa va a ser nuestra próxima capacitación, en donde el tema de incendios va a ser protagonista y va a ser el principal, y van a participar conferencistas de ANRACI en ese tema. Así que, bienvenidos. El área metropolitana junto con ANRACI y los otros patrocinadores de este evento, les damos esa cordial bienvenida. Gracias por estar aquí y de verdad disfruten mucho de las conferencias y del aprendizaje. Muchas gracias.
Bueno, finalmente quiero aprovechar que el presidente de nuestra asociación acaba de llegar. Él había tenido como un inconveniente ahí en su desplazamiento, pero acaba de llegar, y vamos a aprovechar que el ingeniero Alex Rodríguez nos acompaña para dar un pequeño saludo. Ingeniero Alex.
Buenas, ¿qué tal? Muy buenos días. Gusto, mi nombre es Alex Rodríguez, presidente de ANRACI Colombia. Inicialmente solamente quiero darle la bienvenida, agradeciéndoles a todos su participación y estar acá. Me disculpo un poco por la tardanza, yo tuve un contratiempo en la llegada a Medellín, pero pues la idea es que estamos aquí y agradecemos la participación de los miembros acá del municipio, del Valle de Aburrá, a Mike de IFCA, que muy amablemente nos acompaña, a todos los miembros de la Junta Directiva, nuestros panelistas y expositores, a las personas que nos apoyan con la muestra comercial y a nuestro director ejecutivo, que muy amablemente siempre realiza este tipo de eventos que van en beneficio de nuestra comunidad contra el incendio en Colombia. Entonces, solamente quería, como mencionaba Hugo, darle la bienvenida. Vamos a tener una serie de conferencias tanto acá en el salón principal como en el alterno, en donde serán bienvenidos y esperamos que sean de su agrado y que puedan todos participar de primera mano y con las consultas y las dudas que tengan al final de cada uno de los seminarios. Muchas gracias.
Bueno, ya finalmente entonces, para lo que les pueda servir y ayudar, mi nombre es Hugo Torres, Lina Rueda también está apoyándonos. Cualquier cosa que necesiten, pues con mucho gusto, y vamos a dar inicio ya a nuestras conferencias. En este salón tenemos prevista la conferencia que se titula Sistemas de Protección contra Incendios, aplicaciones en instalaciones comerciales, a cargo del ingeniero Hüseyin Kunruku. Hüseyin, me perdonas por la pronunciación, Hüseyin viene de Turquía. Hüseyin es gerente de exportación de Duyar Bad Company de Turquía, vive en Estambul y lidera un equipo de profesionales que atiende a más de 45 países en 4 continentes. Es miembro de la Junta Directiva del International Fire Sprinkler Association de la IFSA, graduado del Departamento de Ingeniería Mecánica de la Universidad Técnica de Black Sea en la ciudad de Trabzon, Turquía. Tiene un MBA, graduado en el año 2001, y se especializa en mecánica de fluidos, diseño y desarrollo de válvulas para sistemas de protección contra incendios, rociadores automáticos contra incendios. Hüseyin, un segundo, que yo creo que debe estar afuera, lo llamamos. Sí, mira, yo por detrás. No está. Él está afuera.
Está afuera, pero no escucho. Entidades de gobierno, aseguradores, universidades. Eso, doctor, muchas gracias.
Para aquellas personas nuevamente que lo necesiten, el servicio de equipos para traducción simultánea está aquí saliendo del salón y la cafetería queda a mano izquierda como anuncio parroquial para el que necesite algún tipo de servicio de alimentos. Sí, muchas gracias.
Thank you so much, gentlemen. Hello, everybody here. My name is Hüseyin Gümrükçü. It's writing in here. I'm coming from Turkey. And first of all, so much thank you to the guys, gentlemen from ANRACI, who is invited us to here to participate in this really important conference. So they also asked to share some technical stuff, and we choose this topic, I guess, can be some interesting for you. The demo in this presentation is fire protection applications in shopping malls. So it will take around 30 to 40 minutes to pass this session. If you will have some questions, I can answer you. So, as every one of us is observing that shopping malls are changing people's habits and social behaviors. So it has been another popularity places, especially in the last 20 years. And it is new economical attraction points and people social collecting points. This fact is making malls very intensive and situations in malls in different countries, like you see in China, Russia, India, Qatar in 2012. Fires in malls threatening human safety and life, together with the liability of property and business. It's around in the last 10 years, it's reported more than 1,000 people died in the fires in malls. So, of course, billions of dollars lost in business. So, if we pass now to mention about complete fire protection systems in shopping malls, we can divide it into 4 sections like here. The first, architecture. The second is electromechanical and automational systems. Third, stable fire extinguishing systems. And 4, specific fire protection systems. Now, if we take a look at architectural side, so it is mostly coming from the project, from the civil project, as we can count it, fire escapes, staircases, direction signs, fire exits, heat and smoke ventilation, pressurizing smoke, extinguishing and breathing air supplies. So it aims rapid, healthy and safe evacuation. Actually, the mechanical side is not too much interesting on this business, except the ventilation side, but it's coming mostly temporarily by the project. The second is electromechanical and automational systems that we can count as smoke and gas detectors, as it is in everywhere now, flow switches, and the complete fire alarm systems in the COE here. It provides detect and indicate the fire, and besides found out the location of fire in complete area, various fire area. So, as you now hear, fire detectors have 2 types, ionization type, photoelectric type. And the right side you see a specific characteristic flow switch activates mechanically by water flow. It indicates certain location of the fire by sprinkler head activation. So the system down there is collecting all the data all the data from system, from different detectors, different fire alarm devices, even from flow switches, mechanical, and it is processing everything on demand, and it's an intelligent control system for monitoring all the fire protection system in the building. Now we pass the third section to stable fire extinguishing systems codes for shopping malls. Yes, according to NFPA, shopping, trade, office, and entertainment facilities, if larger than 2,000 square meters, you're supposed to build a fire protection, complete fire protection system there. Life safety consideration of stable fire extinguishing systems. Actually, if a well-designed and assembled fire protection system exists in the building, it's usually no reported multiple deaths. It's working. Life safety entails combustion products are limited with extinguishment in the incident stage. Controls 70% of all fires with 5 or fewer sprinklers activated. This is a general overview which any building contains these systems all together, but I remarked some of them for mall application. It is including mostly stable fire extinguishing systems, and it is mostly water systems and sprinkler, fire groups, fire hose cabinets, and the sprinkler system usually is being two types, as you know, wet and dry pipe systems for open and closed areas. This is I will not go so deep to the details of wet pipe systems, but I put this slide in here for just reminding you how it is contending from the street until inside the building. It comes mostly from a city main line. There is a municipality fire hydrant in here, which is yellow color, and then a post indicator wire, fire department connection, and the fire hydrants which belong to the building. So then underground fire line comes and enters inside to the wet pipe alarm out in here. It should be located in the building for the risk of freezing in the winter conditions. So enhanced sprinkler system is building parallelly, as you see in here. There are a lot of different patterns for that. It is coming from the project. And there is an inspection test line in here, mostly includes a test and rail fire extinguishers in here for using local fires. And that's it. This has including, I guess, 100 slides of the presentation. It's another demo, but all of the malls, which is larger than 2,000 square meters in internal areas, you build this system. And this is also explaining the fire pump loop for sprinkler system. It includes an electrical pump, diesel pump, secondary pump, OCN valve, gate valve, ball valve, non-return valve, butterfly valve, and so on. It's a complete system, mostly already producing as a package and installing as a scale, big or small one, according to the building scale. This is a specific system which is using in all types of the buildings. We call it hybrid system, which is including wet and dry system together. Actually, this is a perfect system. I mean, it's including everything. You are just adding or missing something from this system. As I would like to explain, that there is a main storage tank and fire protection pools. Tanks should be, the surface should be open with aquastat, and there is a master pump group here. There's a jockey pump for testing and commissioning mostly. There's a compressor unit for dry system, and different alarm valves in here. This is selector valve set, this is dry valve set, this is wet pipe set, and it's everything is combining in the same collector here. And one of them is, this yellow line is going to the dry side. Unless the dry alarm valve is located internally, the sprinkler system outside must be open the freezing conditions. So wet pipe systems in the other side, it is assembling internally. So here, the fire detection and control panel I mentioned you is connecting to the checkpoints on these lines and taking all data here to monitor and control fire issues. And here you see a typical wet pipe sprinkler. As I mentioned you that we are 2 slides ago, we are entering the red alarm valve. You see more details in here. You need a fire department connections in here. In case of the fire, if your storage of water is finishing, so you have to supply some water in line to continue to proceed the working of the sprinklers activation. You have a water flow alarm in here, which people should hear well in common environments. We call this fire the riser and the cross main and the sprinkler systems. Similar system for dry pipes. So the only difference in here that you use another type of the valve here, dry valve, which the blue section in here symbolizing the water comes out the clapper. After the clapper, you have to fill up the air or compressed gas in inline, as you see in yellow. So it is protecting the pipes and sprinklers against freezing. So this is a fire department connection. There are some conditions to put it, but it should be visible in outside of the building. And this is familiar for you, the fire hose cabinets. Necessary to use it mostly in high buildings and shopping malls as well, because it requires to use it in the buildings which is bigger than 2,000 square meters. So I mentioned you another system after stable fire extinguishing systems. We call it specific fire protection systems. This name I gave, but one of them is so much characteristic in mall application that the food courts are one of the most common fire starting source in malls. So in my latest years, this industry is developed a lot. Kitchen extinguishing systems is something like this. It is totally different than wet or dry systems. It's activating by detectors and the heat increases, and so it's contacting a power and gas supply and here and automatic fuel shut-off because they use gas on cooking process. We have to cut off it in case of the fire. And then as a storage cylinder in here, it's contacting extinguished gases and chemicals inside. So it's activated by the detectors, and we can call it independent system for each kitchen, which is located in food court. But the only thing that we are taking again some signals on here and connect it to the main fire automation system to monitor also the locations of the kitchens in case of the fire, provides safe evacuation. I would like to mention about some key points, mostly for parking areas. So we can separate the parking areas to 4 sections. Like there is one is full open. Another one is kind of half open. It's out of the building, but multi-floors. It's semi-half. Some open atmosphere. Another one is internal parking areas, which is mostly in my country is very common because we don't have too much land around the building, so we take the land and we put the parking areas downstairs. It is mostly single floor for smaller malls, but the most dangerous is when it is a multi-floor. 2, 3, or 4, sometimes 5 floors down there, the cars are locating, and it is really dangerous environment, especially it's open area to everyone's access. So what is suggesting in here, the full open parks, we can consider, of course, the low hazard places, and we can equip it there on a couple islands according to codes. But multi-floor half open, so we can consider medium hazard, and we have to install a sprinkler system in there because there stays the floors in there, and it is available to assemble a common dry sprinkler system. So, and in case of the fire, people's evacuation is not that easy like the run time. So, internal parking areas can be considered again medium hazard because evacuation is a little bit easier than multi-floors, but multi-floors we have to be careful about, especially in project side, and the evacuation system also must be very well planned and applied. It should contain a good wet sprinkler systems inside or dry. It's in charge of the project guys. Okay. Another key point that I would like to mention is about architecture and higher ceiling heights. I mean, it's being higher and higher every day because the architect is providing more beautiful and comfortable environments. It seems somewhat majestic, but there is a kind of blind point of fire protection applications because all the devices that we are spraying the water is usually designed for lower heights. I mean, a sprinkler is working 3 to 4 meters, maximum, let's say 5, and then you cannot use it. And then you have to change the type of the sprinkler in these areas especially. So, as you know, there are 3 types of alpha standard sprinkler here is extra large surface, extended coverage, and EFSR. So here you can see a standard spray of the umbrella of water, and this extended coverage umbrella in here. So it can be an option if the height is going upper than 5-6 meters, but there are, in left side as you see that malls, these areas, I guess the main place, main entrance or whatever, it's around 16 meters and you have to spread water inside. So then regarding, according to the areas, architectural structures, so you have to use specific types of the sprinklers. Another key point is complicated architects. As you see in here, they are making curves, different shapes, floor types, and cloud types, and whatever. It's up to their imagination. So, then it's making people is walking in here, but not all the time. There's a ceiling in there, but there's a wall in there by this shape. So, when you are preparing a sprinkler systems project, you have to design where you will locate the sprinkler, and in here, right side, I would like to show you. So there are the patterns for sprinkler water suppression. So you have to take care of this, put in your project and simulate where you are covering by the sprinkler, and then you assemble it accordingly. This is the end of the presentation. If you have any question, I can try to answer you. If not, thank you very much for listening.
Bueno, muchas gracias a Hussein por su conferencia, muy amables. Continuamos con la conferencia de Mike Bosma de Viking Corporations. Nos va a hablar unos temas respecto a la compañía. Ya, okay.
This is the
Storage or
yeah, storage. Yeah, that one. Yeah. Okay, good.
Thank you.
So just direct it on here.
Yes.
Just hit the arrow.
Yeah. Yes.
Got it. Okay. Okay, good. Good morning again. I am going to speak to you on the viewpoint of the manufacturer. I said welcome earlier in part of IFSA. I work for Viking Corporation out of Michigan in the United States. We're a manufacturer of fire sprinklers, both in North America, Europe, and China. We supply a full line through an integrated supply chain, and we offer a full line system. And so we have quite a bit of experience in what products sell and what applications. And I was asked to address the topic of storage, right? Storage is something that's been a very evolving field in the recent years. And I'm going to take you through what we see as a manufacturer and supplier, and actually in some parts of the world we're an installer in the name of Minimax. But I want to take you through what we see and recommend some good practices. Before I start, I'd like to ask real quick by show of hands, which that means raise your hand. If you're in the installation or the contracting business, would you raise your hand for me? Okay, good. That gives me an idea. All contractors always sit in the back of the room, if you didn't notice that. Okay, storage, right? It's changed a lot for a couple of reasons. And I like to put it in the terms of we all need more places to put our stuff, right? We have more stuff. Society is getting richer. We demand better foods at our restaurants that have to be transported. And the overall business model in all the developing countries is requiring a logistics chain. You can only look at companies like Amazon and look at, I drove here last night, I think I saw at least 3 beautiful shopping malls, probably missed several others. And it never ceases to amaze me how the society grows and we all need more stuff. The problem with that is we stack it high, we get it in places it's difficult to get to, and probably more importantly, we're starting to package our stuff and store our stuff and make it out of basically petroleum-based products, plastic. So the plastics have invaded the materials of construction. We're stacking them higher. We're also trying to compress them, which nothing feeds the fire better than having your fuel stacked with gaps and make it difficult to get to. So a lot of technologies have developed in the last 20 years for storage, and I'm going to try to walk through some of the steps that you need to be aware of. And I'm going to try to recommend something in each of these categories. You can use it or not. It's my observations as a supplier of storage products around the world, things I've observed as we've sold these materials. Probably the most important thing, or the start, is what are you storing? What is the commodity classification? And in there, the question always comes up, is there plastic involved? And almost inevitably it is. You may not think it is. They may say, no, it's food, it's butter, it's fish, it's some sort of a metal part. But we box it with cardboard, we wrap it in plastic, and we put it on polystyrene. right? So we need to know the plastics. And in NFPA, they talk about Group A, Group B, and Group C. And I'll try to make it easy for you. Almost all plastics are really Group A from a fire protection standpoint. Group B is similar to Class 4 commodities, and Group C is similar to Class 3 commodities. So so the real thing when you're looking at is, do I have plastic in this job? And inevitably, you probably will have Group A. The other half of that equation is packaging. Are you cartoning your products or the uncartoned, right? Are these expanded plastics or unexpanded? And I got a couple examples, but the expanded plastics have air injected in them. Think of styrofoam balls or polystyrene trays. They burn, they melt, they're fluid, they can move the fire around. They're very dangerous, right? So they really add both the fuel load and the spread of the fire. So looking at your commodities is the first thing. And how you store them, what I'm putting here may be somewhat controversial, but we've seen the world move towards an effort to get away from what we call ANRACI sprinklers. Now it seems strange, I'm a fire sprinkler manufacturer, and we're advocating not using ANRACs, but the levels of sprinkler within storage create inherent problems for the owner to where they're looking for in-sealing systems that will protect a wide variety of applications. In fact, in North America, Europe in particular, and in South America, we see a move towards what I call specification buildings, where they don't know what's going to be stored, so they're looking to cover the broadest commodity possible. And so typically, if you're involved in that, if you can get 1 through 4 in Group A covered, and usually that's an ESFR product, that will give you the most flexibility. It's not everything, and I'll try to show you some of those. So the most common plastic, and this is a picture of how we test, is an unexpanded Group A. That represents the majority of plastics you find in storage outside of the special things that I'll talk about in a minute. What we do to approve a sprinkler is we put the unexpanded plastic in the form of a plastic cup in a carton container, and we stack them in 5 foot cubes. Sorry, I didn't use metric there, but that's the way the laboratories use it. And at UL and FM, which are the 2 laboratories that conduct fire tests for sprinkler products in the world for these type of products, we stack those to the ceiling and we light them on fire. And just to give you a feel for how we do this, in the old world, it was spray sprinklers. You heard the previous speaker talk about their spray sprinklers and extended coverage, and we evolved the ESFR. The fire test, and this is the middle of the one I showed you, what we do is do a back-to-back rack in the middle and an aisle width of 8 feet, 2.3 meters, 2.9 meters. And the test criteria is you light it, the sprinklers has to drive the flame down and prevent flame spread. Cannot go to either end, and cannot jump the aisle. That's the simple test that we do. It sounds simple. It's about $100,000 US per test, and there's at least 12 versions of that test. So just to try a sprinkler, it's about a $1.2 million US attempt. And more often than not, you have to do it repeatedly. They do it between and under. It's a whole other talk. But the idea to show you this is, as storage has changed, and when you hear folks talk about ESFR, or in some cases CMSA, and I'll tell you the difference in a minute, it's addressing these type of fires which represent the new way we store with the amount of plastic that's in there. And really what it does is it drives water down. Our previous speaker had a drawing of the water pattern. ESFR drives water straight down and only wets to a limited degree, where a control mode spreads water across. You need that with these hot fires. So the name early suppression, fast response, the idea was to combine a fast-acting element and to drive water into the seat of that fire before it gets big. And it's been very effective, very common, and you'll see it evolving dramatically. And I'll talk about that today and a little bit this afternoon. I'm going to be Jim Lake this afternoon for my FSA, but we'll show you how that world is changing. This is an example of an expanded Group A plastic. It's something you don't normally think about. It's just a polystyrene tray, but it's expanded, and in the right quantity, you could up your fuel load rating significantly, maybe 2 classes. Beyond the 1 through 4 in Group A, we get into what I would call special storage situations. And these are ones that I think people probably know, but you should be aware of. If you run across tires on the upper left, rolled paper storage in the lower left, baled cotton in the upper right, or carpet. I don't know who knows the problem with that one on the lower right. It's just rolled carpet, but the bigger issue is it's solid shelves, right? So once you do that, you pretty much make it very difficult to use a ceiling-only sprinkler. So these are all special situations that go beyond the norm and typically require, as a best practice, a unique approach, right? So they're different. The other thing that's changing in the business that you need to be aware of, and I don't know how this is in Colombia, but to the extent that we store our products on pallets, historically they've always been wood, but now more and more we see plastics, polypropylene, high density products. They hold their structure and allow air gaps to pass, and they're basically a flammable liquid formed into a structure to hold your material. So they're part of the fuel load. So as you use plastics, or your client uses plastic pallets, you could change the rating again. So again, we go back to the recommended practice. If you're covering group 1 through 4 and class A, you're going to cover all these. If you try to segment to just a class 3 commodity, just a class 2, as a warning for good practice, it's very difficult to confirm that. The other part of the equation, if you know your commodity, is how are you storing it? And it's is it a open frame rack, which is just kind of an example at upper right. These are the most common ones that run across. They're either single row, double row, multiple row. If it's a rack, it has to be open frame. If it has solid shelves, we cannot use ceiling-only protection. So whether it's a single row, double row, or multiple row, it's a good practice to make sure you maintain your flue spaces as well. NFPA is very detailed about how the flue spaces should be spaced and how they should be kept clear. That'd be the space behind the commodity and the space alongside it. That's needed not only to allow water down, but believe it or not, when you test, it allows the heat to travel to the ceiling. So when the sprinkler system in a warehouse activates, those flue spaces actually transmit the heat to the ceiling to allow it to act fast, which, very simple principle, put water on the fire when it's earlier in the process and a better chance of extinguishing it. So the racking will take one of 3 forms, most likely. Then you've got storage options. Maybe you're not using rack. It could be a solid pile, could be a palletized, could be shelves or bin box. Those are all options. NFPA and FM cover those in detail, but those are the main ones you see. What I would recommend, what we see, it's always good practice to avoid, if your client can do this, open top containers. And the reason for that is it's no longer covered under ESFR or many other schemes because it collects the water. There are ways around it. You can put covers over it or you can put different boxes, but they really drive the cost up significantly. The other thing to maybe avoid is heights over 14.6 meters. Today, ceiling-only protection is really only practically available up to a building of 14.6 feet. The other thing is solid shelves. Solid shelves pretty much mean you're going to use NRACs. And I love NRACs, so we have to sell the sprinklers to go in there. But it's something that most owners would like to avoid. Typically what we see, it's been estimated that of the buildings going up, maybe 60 or 70% are designed for ESFR protection, specifically to placate the owners who do not want sprinklers in their operating area where they're loading and unloading materials. The last one too is good practice, not just for the install, but keeping those flue spaces intact. This is simply an example of a single roll rack. It's your very basic way to store. Double roll rack, these are terminologies you'll run across in NFPA. double row rack, like the name implies, is simply a row on each side with a space, or multi-row. There's actually, the lower right hand as an example, there's often a row in the middle. Maybe that's a feed for the back product or how to replace it. So pretty simple, but these are just give you some visuals of what they would look like. The other issue, or the next issue, I guess I would say, is how high is the material being stored? And this is critical. I mentioned the, the 48 feet, and the height is changed a little bit recently. But the height of storage is the primary factor determining how much water is going to be required. And from what our customers tell us, the cost of a system almost always comes back to the water supply. Is it a pump? Is it a contained source? What is the cost of that water? And the height of that, the higher you go, the more water it'll typically take. So any storage, and as a definition, anytime you're storing over 3.65 meters, that's considered storage for NFPA standards. So NFPA and FM both, they use a graduated storage height in 1.52 or 5 foot blocks, and those increments are considered cubes of storage. So what you do is you need to know your height of storage and the height of building. So typically it might be a 40-foot building with 35-foot storage, or a 35-foot building with 30-foot storage. That's normally what you would do. That's how the charts are set up in NFPA. And recently we've discovered, with the help of one of the laboratories, UL out of Chicago, is if that space to the top of the ceiling, the top of the deck, is more than 20 feet, that actually is another higher risk and a whole other issue can evolve, and ANRACs could be required. Now, when you look at the height of the ceiling is measured to the deck. So decks are made of many materials. Many times it's a corrugate that's like a Z shape or a pattern. You would typically, if the groove in the ceiling structure is less than 76 millimeters, you can measure to the bottom of that structure. So you can measure to the very bottom. If the Z pattern is deeper than 76 millimeters, you have to measure up to the top of that gap. The other option is to put insulation below it, and that allows you to measure to that. But the ceiling height is a critical measurement when you're establishing your criteria for water supply and design, whether it's FM or NFPA. Both FM and NFPA use graduated ceiling heights. In other words, they go at 1.5 meter seconds. And all storage tests for the ceiling-only sprinklers are conducted in flat, smooth ceilings, which is a 2-inch and 12 slope. I believe that's 18 degrees or so. And that's critical because if the ceiling's sloped, that eliminates the ability to use a suppression type of sprinkler. You have to go back to a control mode type of, the old-fashioned spray sprinkler with NRACs. There is a project going on right now, and they're testing the effective slopes and some of the changes. And I think by the end of next year, you're going to see that will come out, allowing you to use suppression in certain slopes and certain heights with different water supplies, which should be handy. Typically in my part of the world where we get snow to great depths, it's very difficult to keep a flat roof for a very large building. They need the slope to shed the water and snow. So the other issue is obstructed construction. Is it cross beam? Is the I-beams deeper than a meter, than half a meter? That's something to know. And the other part of that, as part of how you lay it out, is you need to be aware of the distance from the ceiling to the sprinkler element. So in that sprinkler, the ESFR, which is typically pendant, there are some that are upright, and the control modes are mostly pendant and some upright. That 13-inch minimum is set from the ceiling to the middle of the heating element, which in most cases these days have been soldered. Viking's a bulb company, and we're going to launch a product of ESFRs with bulbs in them. But typically, at least in the last 20 years, the solder link, because it's metal, collects the heat much more quickly and allows us to activate more rapidly, which gets test. So that's been, the industry's been using that to date. You're going to see that change in the near future. Now here's a point, and it's more than I can cover in just the 45 minutes I have, but NFPA and Factory Mutual are the two largest influencers of storage arrangements. NFPA uses a standard, a consensus-driven standard, typically in concert with UL. You may have heard of laboratories UL, laboratories FM. There's other worldwide laboratories, obviously in Germany and Japan, but when it comes to storage, UL and FM have been the primary entities that have been testing these schematics. And NFPA, which is UL uses NFPA lockstep. FM has deviated from NFPA. It's something to be very aware of. You need to know whether your client is getting their insurance from FM or they're trying to comply with UL. And I'll show you a couple of examples here. But FM historically has been a more difficult or more stringent requirement. And that's not the case always anymore. FM has tried to simplify storage, and I believe they have, but that might just be in our mind because we live this world, and it's gotten a step closer to being simple, but I don't know that it's still totally simple. But as advice, I would tell you, and it might be biased, I would tend to look at the FM requirements whenever you can. They're more competitive, they're easier to use, there's more options. It's opened up a whole new realm of possibilities. UL follows NFPA, and that's okay. And it can be a little more complex to follow what can be used in that scenario. If you didn't know it, UL is an underwriter. That's all they do is underwrite. So they rate these products. They call it a listing or classification. And their member insurance companies use that listing, and it allows them to recommend them to their schemes through a whole variety of underwriters. Factory Mutual, on the other hand, is an insurance writer in and of themselves. When they issue an approval, it's for their insurance. The way I like to phrase it is Factory Mutual has to write a check if there's a loss. So they test a little differently, historically a little more aggressively, but I would say as of recent, they might be a little more flexible based on a whole bunch of fire testing that they've done in this arena. So depending on who's the lead authority, you could have different requirements. There's one note, and I'll try to point this out, and it's about ESFR K14s. And this is not just Viking, it's every manufacturer. That was the first ESFR product. That could go to 40, you could cover warehouses up to 40 feet. You could cover 12.2 meters. You could store up to 35 feet. But what they found about 4 or 5 years ago now is that 5 feet delta, UL decided to test it with a bigger delta. So they changed the distance from they had some fire losses. So they changed the distance from their test commodity to the ceiling to 20 feet. What they found was the K14 didn't pass anymore. So the K14 is now limited to 35 feet, whereas the K17 and 25s and 28s and 2019s can go higher than that. So it's a fairly recent change, and it's now embedded in NFPA. It took a little while. It's in the 2013 standard now. Okay, I'm going to try to relay to you the differences, and this might be from a contractor perspective, because as a contractor, we're always thinking, I used to be one years ago, but we're always thinking about the cost, right? We have to bid it and comply. So the cost to us comes not only from the basic design, but obviously pressure and flow, because pressure is generated by our pump and the flow is our water supply. Often the two biggest impacts are our cost. This, I tried to give you an idea with the changes. I compared the K22 ESFRs and the K25 ESFRs, because those are where the industry has gone. That's the most current product, I would say, that we use today. So these boxes, if you think about it as 4 boxes, there's 2 in each row. You got the FM criteria on the top row, and the UL criteria on the lower row. And this is the different ceiling height configuration. The same, like the K25 is the same pressure, so it's 2.7 bars, but if we use the K25, the water flow jumps to 600 liters a minute, right? So that times 12 can be significantly more water. The lower left is the UL requirement. that same building, that 40 foot or 12.2 meter, is 2.75 bar, same as the FM, but less water because it's a K22. And if you go to the K25, the difference is even grander, right? It's the 40 foot or the 12.2 meter, the 2.75 bar only needs to generate 302 liters. So the flow can range from the high of 600 liters per sprinkler per minute to 300. So it's a pretty wide variety depending on which approval agency you're using. So the way I like to phrase it is, the upper left box, if you will, is the best pressure, and the lower right box, if you will, is the best flow. But you need FM to use the upper line, and you need UL to use the lower line. So it's a little confusing, and FM is actually doing training on this to get you more involved in how they do their standards. I'm just trying to give you an overview so you know what's going on at a high level, or can be aware of it. To give you an example, this is an FM chart. This happens to be, has anybody seen these charts before? Do you use them? Maybe not yet. This is the way Factory Mutual is approaching storage now. They no longer use the term ESFR. They no longer use any term except storage sprinkler, right? So you'll see this is one of the tables, which there's seven or eight, and you get your commodity and how you're storing that. And it says table 3. This is sealing only protection for carton unexpanded plastics. It's in a pile configuration. So these are your options. So your ceiling height on the left, you got everywhere from 4.5 meters to 13.5, and your style of storage sprinklers are across the top. And you'll notice they have wet pendants, they have wet uprights, and they have dry. So there's more options. Obviously, when you get to dry, the requirements change and the possible ceiling heights get lower. But it gives you a range of options for FM-approved products. And these charts are going to be the future of what FM is underwriting around the world. They've been preaching. I'm not from FM, but we see this effect going on. This just gives you an example. The green color means it's a 250 PSI hose stream for only 60 minutes, whereas some of the other schemes are 500. So the green are typically a little more advantageous. If you're looking at this, if they're green, it means you got a little less water flow. So, I don't know if you know the word nerd. I'm going to try to, this is what sprinkler nerds look at, right? We make sprinklers, and we're so into it, we've made these terms where the average user, they just think of it as a sprinkler. Can I use it in my hazard? Well, NFPA has 3 types of sprinklers identified. And I'll quickly cover them to give you, if you can grasp this concept, a lot of others, these special sprinklers make a lot more sense to you. There's the good old control mode density area. We call that CMDA. Those are the sprinklers that we've used since the 1960s. And they just simply are a density over an area. You back into how many sprinklers, minimum starting pressures of a half a bar, and you design it accordingly. We're used to that. It's still available. What's evolved over the years is what they've identified as control mode specific application. And those are when manufacturers like us say, well, you can store 28 feet in a 35 building with 20 pounds with my K11, right? Or my Quell system, or my, those is a whole bevy of special sprinklers, my K25 upright and freezers. Those are all CMSA, and they're typically, as opposed to density area, they would have a number of sprinkler designs. So you would design to, say, 12 sprinklers at 2 bars, or some formula based on the hazard. That's not a category they want to continue. They're trying to make everything fit the other 2, but they decided they had to have 3. The other one is a little more common, and that's the ESFR. We all talk about that. It's become a trade name, and it stands for Early Suppression Fast Response. And again, like the CMSA, it uses a number of sprinklers. Most ESFR are 12 sprinklers at a set pressure for a hazard based on ceiling height and storage height. So that's a separate category because they've identified it as typically a 12 sprinkler design, and that's all laid out in the NFPA. So they have 3 categories, And that's how the book is laid out. And we'll talk about that this afternoon. I call factory mutuals charts the fourth type, because FM simply stop calling control mode or specific app or early suppression. They just call them sprinklers. So that's FM's attempt to simplify this. There's sprinklers and there's storage sprinklers. And that's almost another type of sprinkler you'll hear the industry talk about. So, I'm getting close to my time, so what I'll tell you is, what have we learned? I can tell you, and I've been at Viking 25 years now. I ran R&D, I ran the factory, I've been in sales, so we've seen a lot of things evolve. And as we've tested these products and brought them to market, the one thing we've learned is larger K-factors are more efficient in storage applications. Not only because of the lower starting pressure, but because of the drop sizes they create. The old densities with K-factors less than the US 11 generate too many small droplets and the heat wraps them away. So you're going to see more and more large K-factors going forward. NFPA limits K-factors based on sealing height. They've mandated that going forward it'll be K8 or more. Factory Mutual likes to see K of 11 or more, and I apologize, these are imperial K-factors. But we know the larger K-factors produce larger water droplets, and that helps us penetrate that fire plume. You need a certain amount of velocity, but you also have to have mass in that drop, or it doesn't make it. It actually turns into steam and blows away. So we've learned that's kind of the way the industry's going, and that's probably the future of where things will continue to go. So I don't want to overstay my welcome, but I wanted to touch base on a couple of unique products, and I'll just quickly go through these. But there is a new type of ESFR that's actually dry. It's an ESFR that you can use just like an ESFR. You can put it in a 45-foot building. You use the same design pressure, the same number of sprinkler design. The difference is it's on a dry barrel. So it's a 1 meter barrel that allows it to attach to a wet system above the freezer. It's becoming more and more common as we develop our food supplies and the freezer systems to carry those around. Those are flammable based on the packaging. This is a great product to use in that application. This is an example of a control mode. The K240, which is something you see if you're still doing CMDA. This is another control mode sprinkler. It's a CMDA and a CMSA. It's not one that we manufacture, but one of the tricks of the manufacturers are most of the storage sprinklers we're talking about are set spacings. They're 3.2 meters square, or 100 square feet, if you will, or 10.2 meters. These start to allow more generous spacing, more advantageous pressures, different configurations. So they're all specialty applications that us manufacturers will be advocating. There's one thing I'll make you aware of, and this is for ceiling heights that are going above 48 feet, right? Or above 12 meters, if you will. There's a scheme in FM now, table 16 we're calling it, and that's an in-rack design that allows one super in-rack of ESFR sprinklers and a ceiling overhead that allows you to, if you think about it, to stack the ceilings. So if you had a 12 meter level to an in-rack and you put these ESFR in, you can go another 12 meters and cover virtually a 24 meter building with an in-ceiling and one level of super in-racks. It's a fairly new scheme. It's only for FM. You won't find this in NFPA. But if your client is dead set on going higher than 13 meters, this is one very effective way to do it, using FM as your guideline. This is a more specific app. I'm going to bounce through these. ESFRs, just real quickly, come in different configurations. You can get the K200, which is a US 14 independent. You can get it upright. You can get the K17, which is a K240 upright and pendant. Effectively, the K240 product has been supplanting the K200. It's very more efficient in pressure. All manufacturers make it. It's been something that has been the sprinkler of choice in most of your average warehouses. The next level, if you will, is the large. I'll call it the 25 millimeter thread products, and they come in a K320 to K360. Very similar in performance, but obviously the K320 uses a little less pressure, uses a little less water, but it doesn't have all the coverages of the K360. So you almost need to be aware of both of them at any given time because they have minute differences depending on the commodity. If you look at, to swing back to the FM tables, when you see these tables, and by the way, if you go to Factory Mutual's website, they're free. You can download these tables. They're advocating this scheme. If you take the NFPA commodity classifications and the equivalent table that FM offers, this slide here will tell you what table you can go to. So in NFPA, you got class 1 through 4, group A plastics. Then you got special ones. You got cartoned expanded, you got uncartoned, unexpanded, uncartoned expanded. Those all kind of go beyond the normal water supplies, if you will. So FM has a corresponding table. They use a table for NRAC and a table for pile, palletize, and bin box. So you can see, if you look at all the way through class 4 commodity, FM uses the same table. So as long as there's no plastic, you can use the FM table 7 or 3 if you don't have an NRAC, and that'll cover you for whatever you've got going. I've highlighted the one that's most often used because carton unexpanded plastics, otherwise was class A in FPA. FM's table 8, and if you don't have racks, table 3 are the most widely used by far. Those are the tables that allow you all the options in most of the storage things you do. This is table 8. I won't dwell on all of them, but I mean, if you have this, the same criteria as the one I had before, you can see the ceiling height on the left, the type of sprinklers across the top. This gives you a variety of options when you have a client or working on a particular project that you can use quick response, standard response, you can use dry, you can go to extended coverage, and you can look at the green levels to indicate which has the best hose stream allowance. The 2 numbers in each box are the number of sprinklers. So for example, if we look at the very highest quick response available, we can go to 13.5 meters with a wet system pendant sprinkler. Quick response, we can use a K320 or a K360. Both of those heads would need to be designed to 12 sprinklers at 3.5 bar. So the way the chart works is you simply look to your commodity, your ceiling height, and you can select the number of sprinklers and the pressure required, and that'll give you the options that you need. So it's really it's a good tool, especially working with an FM client. So the thing we learned about the large K factors is that minimum thrust can't be totally ignored. So some people have asked us, you've gone to a K320, what's next? Well, there will be bigger Ks, but at that point, you've kind of maxed out. If you increase the pressure, the overflow kills you from a cost and a water supply standpoint. So we're kind of at that point where we feel like we've maxed out and we're trying to optimize. Large water K factors make large droplets, but they also require a lot of water. But there are opportunities for very large K factors that could be used to go over that 15.2 barrier. One of the interesting points is why is 15 meters the max? And the reason is the laboratory at UL, that's as high as our ceiling goes. We've never had a chance to try to test things higher. And we also feel like at that point you're using so much water, it probably wouldn't be practical. Okay, my last slide, and I hope I didn't get too technical for you. My interpreter is doing a wonderful job. I can hear everything going there. But it's care and handling. And this is something where, as a manufacturer, and I was asked to talk about best practices, so part of me was about what standards to look at, what commodities to classify, what products to use. But I think care and handling is something, a sprinkler is a very durable device after it's installed and put to service. It's still made of a glass ampule. It's made of relatively lightweight materials, especially in the trigger, and it needs to be handled carefully in transit. It needs to be protected from excess heat. It needs to be installed only after the pipe, not before the pipe is installed. And those are just some of the, we pack this little sheet in every box, and I know people may or may not read it, but it is something, depending on your role in the industry, once the sprinkler's installed, they typically, unfortunately for us, last 50 years or more with the right inspection and testing. Any problems we've had inevitably go back to care and handling almost all the time. And the big things are not exposing it to heat in transit, excess heat, I'm talking within 40 degrees of the operating element, not installing the sprinkler until after the pipe has been put in, and then leaving the protective covers in place until the product's installed. Those simple things, and using the appropriate wrench. Although I'll look the other way if you guys care. But that's those things together will make sure the product goes in properly, and once installed and under hydro, it'll last a significant number of years. So that was the extent of what I brought you today, and I appreciate your attention.
Por ahí abajo, la cosa que acá se quedó la forma, acá se queda en la ya no tenemos nuestro mismo el final, porque entonces me imagino que todo el mundo se va a preguntar que no solo se los y esto también es. Sí, vean, hasta acá.
Aquí acá.
Esta fue la que se acabó de Carlos Extra. Después sigue el proceso. Sí, en esta estamos. Luego después de esto, el almuerzo y vamos a para acá está
¿Qué tal el tour?
estas personas. Y entonces, después de los almuerzos, sí, efectivamente, después de los almuerzos, hasta las 4, a las 2:45. O si él quiere interpretación del resto de presentaciones. Vaya. Entonces, esta que les lleva. Estas hechas de Contra. Pues es como que algo ahí, porque dice que el proyecto de
Yes. Yes.
Ya traigo las cosas.
Good. How are you? Good. Okay, good. From Medellin. From Medellin. Okay. Okay. Very good. It's a beautiful city. Yeah. Sorry. Yeah. The office is in Michigan. Oh yeah. Yeah. Storage, yeah. Mostly spring. So some systems, valves and things.
How are you? How are you? Good. Good to see you. In USA, last year in Medellin.
Vi la conferencia sobre el programa. Muy bien, y bastante sencillo. Y tocó salirme de la última parte, la información la presenta como Protección FPA. Todas las tablas nuevas. Y la información sí, perfecto. Pero también usted tiene su corporación, simulación de CFE. Y el modelo que tienen también desarrolla la simulación con la activación de proporcionadores, solo generación de calor, movimiento de puedes mencionar que en América Latina se trabaja con el mundo de restricción. Cada vez se hace más interesante para poder utilizar modelos obviamente también desde el punto de vista práctico dice que aclarar que se tiene que ser la administración correctamente cargas caloríficas, una serie de condiciones que son las que pueden definir el comportamiento para poder llegar a una solución. Inclusive en FPA pero hay que hacer al menos 8 escenarios distintos descriptivos, simulando distintas situaciones que serían los diferentes escenarios para determinar qué es.
Bueno, buenas tardes. Vamos a dar inicio al panel de innovación y tecnologías en sistemas de protección contra incendio. Pedimos un poco de excusas por el tema inicial que se nos agendó un poco, se nos cortó un poco la agenda inicial y eso nos un poco de desorden en el horario inicial, pero vamos a tratar de ponernos al día. Voy a dejarnos con nuestro moderador, el ingeniero Javier Sotelo. El ingeniero Javier Sotelo es director general de Bosch Ingeniería y expositor y...
Buenos días. Muchísimas gracias.
A nivel latinoamericano en FPA.